Alright, so in our third and final video of our unit, we're going to discuss writing polynomials. And what I mean by that is I'm going to show you graphs of polynomials, and you're going to write the equation, your best estimate at the equation based on the graph that I provide for you. So if you're a steps kind of person, the steps I'm going to be using is I'm going to be identifying the x-intercepts. So I'm going to look at the graph and identify the x-intercepts or zeros or roots, whatever word the problem uses. And we also need to remember when I'm identifying the x-intercepts what it means if the x-intercept quote-unquote bounces off the axis. And then we need to determine is the leading coefficient of the equation positive or negative. Alright, so we're going to have two examples in this video. And again, in these examples, I'm going to identify the x-intercepts. So I have an x-intercept at x equals -2, zero, and 3. So I have an x-intercept at -2, 0, and 3. So when I'm writing my equation, y equals, if I have an x-intercept at 0, that means I have an x out here by itself. So an x-intercept of 0 means I just have a lone x in the equation. An x-intercept at -2 means I have a factor in the equation of x plus 2, because remember the signs are opposite here. Then, if I have an x-intercept at +3, that means one of my factors of the equation is x minus 3. Now, it told me to remember what it means if an x-intercept bounces off the graph. So, if I look at my x-intercepts, this x-intercept, it goes through, it doesn't bounce off. This intercept goes through, it doesn't bounce off. And this intercept goes through the graph and does not bounce off. So if it bounces, that's where we add the squared exponent to the equation. But since none of these bounce, none of these factors are going to be squared. The last thing I need to do is determine, do I need a negative sign out front or not, the leading coefficient. And if we recall from video 6.1 and 6.2, to determine if the leading coefficient is positive or negative, we look at the right arrow on the graph. If the right arrow is pointing up or in the positive direction, the leading coefficient is positive. If the right arrow were pointing down in the negative direction, the leading coefficient would also be negative. So in this equation, my right arrow is pointing up in the positive direction, which means my leading coefficient is positive, which means that I'm finished. And the last two steps were basically just to check, but I didn't actually have to change the equation at all. So this function that I've highlighted in blue will look very similar and match the graph to the left. All right, our second example. So on this graph, I have an x-intercept at -2, an x-intercept at 0, and an x-intercept at 3. So now I know that my function, since I have an x-intercept at 0, I'm going to have an x out here by itself. I have an x-intercept at -2, which means there's going to be a factor of x plus 2. And I have an intercept at +3, So I'm going to have a factor of minus 3. Now I need to check my x-intercepts. So this x-intercept goes through the graph. It does not bounce off. This x-intercept goes through the graph and does not bounce off. However, at 0, the graph bounces off. And what I mean by bounces is if we trace the graph, we go up, we get close to the x-axis, and then we bounce off. If we threw a tennis ball at the origin here at 0, 0, it would hit the graph and then bounce back up. Bounces is not the technical term, it's just what I think best describes what it looks like. If an x-intercept bounces off the graph, we are going to put a squared on the x-intercept that the bounce belongs to. So the reason I put the squared on the x is because the x-intercept where the bounce occurs is at the x-intercept of 0. The factor that belongs to that location on the graph was the x that was out there by itself. If I put a squared on the x plus 2 factor, then that's saying that the graph will bounce at an x value of negative 2, but that's not true. If I put a squared on x minus 3, then that's saying that the graph bounces at an x value of 3, but that's not true. The bounce occurs at the x value of 0, which is related to the factor where it was just x hanging out by itself. All right. The last thing I need to do is determine, is my leading coefficient positive or negative? And just like the last one, to determine if the leading coefficient is positive or negative, we're looking at the right arrow. If the right arrow is pointing in the positive direction, the leading coefficient is positive. If the right arrow is pointing in the negative direction, then our leading coefficient is negative. So if you look at this graph, the piece that I've highlighted, that arrow is facing in the negative direction. So my leading coefficient is negative, which just means I need to throw a negative sign out in front of the equation. So for our second example, this is the equation that will very closely match what's been graphed to the left. So writing equations, that's our last example. So writing polynomials, we need to identify our x-intercepts, determine if there's a bounce that occurs at that intercept or not, and then we need to determine if our leading coefficient is positive or negative, which is based off the right arrow.